So let us try to think a little bit about the intuition behind what we're trying to show. And in order to do that, I think we should consider the payment streams again. Whenever we have one of these exercises, it's super duper important that we look at the payment streams to try and understand what is going on. So the contributions fall as such. At the end of the first time period, the contribution is pi, and that's how it is for k years. And then after year k, there are no more contributions, right? So after year k, everything is just a standstill until the contract ends at year k plus n. That's what I read from this circle up here. Now, this is the contribution payments. How about the benefit payment stream? Well, the first k years, there are no benefits, and it is during these first k years that the contributions are paid. And after the first k years are over, the benefits are paid out. And remember that benefits go in the opposite direction as contributions. And how much is paid out in benefit? Well, 1 unit per year. And that 1 can be any other number, but here it's just fixed as 1. So k plus 1, k plus 2, k plus 3 are the time points, and then the last payment falls at time k plus n. So what is the reason we're looking at this payment stream? Well, how can we interpret this payment stream first and foremost? We can think of it as a savings scheme or some kind of savings contract where you pay the bank. So you pay the bank pi per time period, and let's just say one time period is a year, so you pay it the amount pi each year for k years. Then afterwards, the bank pays you back 1 unit per year for n years. And the way this exercise is structured, you can see, you know that you will get 1 unit per year for n years, but you don't know exactly what the pi is. So it's kind of like this. Imagine that you work for k years and then afterwards retire, and you know that you will need money for n years after you retire. Then you've probably calculated, like, you'll be in retirement for, let's say n is equal to 20, just for fun. So 20 years of retirement. And you've calculated that in order to live comfortably, you need 1 unit of payment each year. That could be 1,000, 10,000, 100,000, or something like that. Anyway, you have a fixed number that you know you need each year. However, in order to receive that from the bank after retirement, you also know that you have to pay in k equals a certain number of years of work. For example, if you're a 50-year-old, then you have 17 years left to work in. So you know that you have a certain number of years where you have to work and pay in a certain amount of your salary. And during those first 17 years, the amount that you pay in will sit there and accumulate interest such that when those k years end, the payments have accumulated enough interest so that you're able to receive your benefit of 1 unit per year during your retirement. So this is one of the ways we might interpret this. Now, why are we interested in determining v of t? Well, recall that I said at an earlier time point, and it's also in the book, that v of t is equal to, well, if we should put it in words, it is equal to the time t value of future liabilities. And what we mean by future liabilities is the time t value of future net benefits. And that means of the future payments B of t minus C of t. And why is that interesting? Well, it is interesting from the bank's point of view when the bank needs to decide how much it needs you to pay in amount pi per year in order for the bank to meet the future liabilities of 1 per year. So that's why we're interested in V of t. So we're looking at the future at any time point t, and then we want to discount all the future payments back to time t in this exercise. And why are we interested in V of 0? Well, we want to know the time 0 value of all future liabilities, because if we know that, then we're able to find exactly what pi the bank needs to charge you in order for fairness to hold. And let us recall what fairness means. So in the book, we have fairness if U of t is equal to V of t for all t. And that means if at any time point t, if we're standing here, for example, at time t, then all of my past payments accumulated until time t, that is U of t, has the same value as all of my future payments discounted back to time t. And why is that significant? Well, that is significant in the sense that in that case, neither you nor the bank get an extra profit from this contract. In the end, everything evens out. Now, what does this thing mean, fairness? Well, apart from it meaning that U of t is equals V of t for all t, this is actually equivalent to the fact that V of 0 is equal to 0, which is the fairness criterion that we use in order to determine pi. And that is why we're interested in V of 0, because if we stand at V of 0, then we are looking at all of the future liabilities discounted back to time 0, right? Then we want the present value of future premiums to be equal to the present value of future benefits. And when I say premiums, I mean pi. So the present value of future contributions should be the present value of future benefits. So let me also write that down here. The present value of future contributions at time 0. So the initial present value of future contributions equals the initial present value of future benefits. And this is the way you should remember the fairness principle. It is that when you stand at time 0, then the present value of all of the future contributions should be equal to the present value of all of the future benefits, because then everything evens out. One last note before I end this and we actually go on to the concrete calculations is there should be a little minus sign here. I know that in exercise 1-2 you actually showed this without the minus sign here, but it's important when we have payments that are not continuous, that if there was a payment at time 0, then we should also count that payment in as part of the future contributions or future benefits. So you should have v of 0 minus equals 0 here. And remember that. So we will get started with the solutions in the next video. I hope this helped you understand a bit more about fairness. And if it's still something that you find kind of tricky, then watch this again or write me an email and we can talk about it.